So let's continue to look at some of the products. What else can happen to the reservoir? There's something we call burrows or bioturbation if you are a geoscientist, and those are just generally, how do I put it, evidence of past life. Okay, so while these rocks were originally deposited, they were living things as at those times where the rocks were deposited. Now, as time continues to go on, as time goes on, these living things, they're either trying to make a living, move around, look for oxygen, look for something, look for food, or try to relocate or something. And the evidence of their movement is this. That's what we call bioturbation. We have different names for the different kinds of bioturbation for those of us who are subsurface scientists, who are geologists. The point here is that these movements, these behaviors tend to affect the quality of the reservoir, which you saw in that video was originally clean, you know, not so porous, not so compacted, very porous, easy to, you know, to carry and stuff like that. But through time, it has become compacted, and then organisms have also created holes in them. And then you also notice that what else can happen, depending on the source or the condition of those reservoirs, they might be very fine grained, they might be very coarse grained that makes up those reservoirs. Again, you can imagine if it is fine grains, if it is coarse grain, you think of it, think in terms of the potential of that reservoir to keep oil and gas, the hydrocarbon potential, the storage capacity. Think of it as you're looking at these slides. And then in other scenarios, you can also have what we call in some kind of tidal signatures, what we call tide, you know, high tide, low tide, you know. So you might have potential periods of breaks in you know, the deposition of that sand, and those periods are marked by what we call clay or mud rocks, you know, forming baffles or barriers separating the reservoir rocks from each other. Okay, so again, think in terms of connectivity, think in terms of heterogeneity as you look at these sections. And then we have what we call phase change. In this case, you can agree with me. If you look at this part of it, if you can see my cursor, compared with the other part of it, it transits from one to the other, not, you know, not gradationally, some kind of sharp transition. But then imagine I'm trying to produce oil, hydrocarbon from this rock. You can imagine that this part of it that has a lot more seal to clay lenses will have a different behavior from the other part that has, you know, less of clay rocks. Okay, so think in terms of permeability, think in terms of porosity, and then the rock strength. Okay, so these are things that continue to happen to the reservoir as it moves from where it started to a new location, and then it continues. Like I showed you, I talked to you about tectonics, how plate movements, how the rock can get folded. So these things all have direct impact on what you originally saw in that video, which was very loose, very porous, very in the original state, and then things begin to happen. They get buried, they get consolidated, they get less porous, and then sometimes they get deformed in the form of fold, and then you start seeing all kinds of reduced behavior or reduced quality. Okay,